Welcome to the video lectures on operating systems. In this lecture, we will learn about operating system services. User and operating system interface, system calls, system services, linkers and loaders. Let's move on to operating system services. So operating systems provide an environment for execution of programs and services to programs and users. So it acts as an interface between the user and the computer hardware. One set of operating system services provides functions that are helpful to the user. So what are all those services? User interface. So when we need to communicate with an entity, we need a ease of transmission of data, right? So that is provided by the interaction facility, that is provided by the user interface. So almost all operating systems have a user interface, varies between, okay, so it can be a command line CLI, command line interpreter, it can be a graphics user interface GUI, or it can be a touch screen, or it can be a badge. So various types of user interface is provided. Program execution. Next services provided is program execution. The system must be able to load a program into memory and to run that program, end the execution either normally or abnormally. Next services is IO operations. A running program may require IO, so which may involve a file or an IO device. And file system manipulation. The file system is of particular interest. Programs need to read and write files and directories, create and delete them, search them, list file information, permission management, all those aspects are coming under file system manipulation. One set of operating system services provides functions that are helpful to the user. Okay, what is that? Based on the discussions previously we had, what is that? User interface, program execution, IO operation, file system manipulation, like that. Communications. Processors may exchange information on the same computer or between computers over a network, right? So inter-process communication facility. So the communication may be via shared memory or through message passing system. Error detection. Operating system needs to be constantly aware of possible errors. So the errors may occur in the CPU and memory hardware and in IO devices, in user program. Anywhere the error may occur. For each type of error, the operating system should take the appropriate action to ensure correct and consistent computing. Debugging facilities can greatly enhance the users and programmers' abilities to efficiently use the system. Resource allocation. As part of the operating system, one of the important services is resource allocation. So for a particular program or a process, the CPU is a resource, memory is a resource, IO devices are resource, file storage is a resource. So using these resources efficiently during the course of execution is very important. So that is taken care by the operating system. It is also called as a resource allocator. When multiple users or multiple jobs running concurrently, resources must be allocated to each of them. So as I said, many types of resources are CPU, cycles, memory, file storage and IO devices. Then next services is logging. So to keep track of which users use how much and what kinds of computer resources, that is coming under logging. Protection and security. The owners of information stored in a multi-user or networked computer system may want to control use of that information. Concurrent processes should not interfere with each other. So that comes under protection, involves ensuring that all access to system resources is controlled. Security of the system from outsiders requires user authentication, extends to defending external IO devices from invalid access attempts. So if you see here a view of operating system services, so at the lower we are having hardware, so the operating system is between. The services provided the operating system now, as I discussed, program execution, facility to program execution, facility to do the IO operation, the file system manipulation, communication between processes, resource allocation, accounting, protection and security, and error detection. So these facilities or these services are provided by the kernel, and if any user programs needs these services, it should initiate these services through the use of system calls. So the system call is an interface between the user and the operating system. Okay. So the command line interpreter allows direct command entry. Okay, sometimes implemented in kernel, sometimes by system programs, and sometimes multiple flavors are implemented as shells. So primarily fetches a command from the user and it executes it. Sometimes commands are built in, sometimes just names of programs. System calls. So it is a programming interface to the services provided by the operating system, as just I have defined. So typically it is written in the high-level language, mostly accessed by programs through high-level application programming interface rather than direct system call use. So if we need to use the kernel services, we need to initiate the system call. That system call will be initiated through the set of application programming interface provided by the corresponding operating system. So three most common APIs are Win32 API for Windows operating system, POSIX API for POSIX based system, which includes all versions of Unix, Linux and Mac OS, and Java API for Java Virtual Machine JVM. So here it is a typical example of how the system call service is initiated by the user program. Okay. So the system call sequence to copy the contents of one file to the another file is the example we have taken here. This example is we are going to copy the entire content of a file and we are going to create another file. So for that, how the system call is initiated. So there is a source file. So now we need to acquire the input file name. So what is the source file name? Okay, so we need to get it from the user. We need to retrieve that input. Then in what file name we need to store. Output file name we need to acquire, that we need to accept that input. Now we need to open the input file. For opening also there is a system call. Through that system call we will open the file. When we are trying to open a file, the system call first operating system checks whether the file exists. If it does not exist, then abort. Okay, so the corresponding process is aborted. If it is exists, then the output file is created. Okay, then we need to loop around the entire input file for completely reading the entire content of it. So read from the input file right to the output file. So reading from the input file is also kernel operation through associated system call. Writing to the destination file is also through a system call until the file is completes. Okay, so then closing the output file and terminating normal. So this is the sequence of actions that takes place during the course of a particular copying of one file to another file. Now how the system call is implemented? Typically a number is associated with each system call. The system call interface maintains a table indexed according to these numbers. So the system call interface invokes the intended system call in operating system kernel and returns status of the system call and any return values. The caller need know nothing about how the system call is implemented. Okay, just the caller is using the facility. So just needs to obey the API and understand what OS will do as a result. Right. So if you see here, the user mode, kernel mode comes into picture here, dual mode. So the open system call is initiated by the user to open a particular file. So the system call interface reads that open command and it understands that the corresponding file should be opened. So it goes to the corresponding directory to look up the corresponding system call number and it goes for the opening of the particular file. So after opening the file, the corresponding control goes to the user mode. So this is how the system call interface is provided through the necessary initiation of the system call through certain APIs. Now there is a scheme for parameter passing for the system call. Okay, so the often more information is required than simply identity of desired system call, right? So the exact type and amount of information vary according to operating system and call. So there are three general methods to pass the parameters to the operating system. So one simplest method is passing parameters in registers. So in some cases maybe more parameters. So if it is a register, only few bits will be accommodated, right? Only few information can be passed. So if there are more parameters, then how the corresponding information can be passed, parameter can be passed. So the parameter stored in a block or table in memory, and address of the block is passed as a parameter to a register. So this approach is taken by the Linux and Solaris operating systems. Now parameters placed or pushed onto the stack by the program and popped off the stack by the operating system. Block and stack methods do not limit the number of length of the parameter being passed. So this is the second way. Right. So if you see here, so the load X, address X. So the address X is loaded into the register. The system call is initiated, and from that particular register the corresponding code is identified. So this is how the corresponding parameter passing through a table is implemented. Types of system calls. What are the types of system calls? System calls associated with the process control, creating the processes, terminating the processes. For creating the processes, we will be using a system call called as fork. End the process, abort the process. Abort means if the process is not executed successfully, it is misbehaved or malfunction or error. So abort. Load the program, process, execute the process, get process attributes, set process attributes, wait for time, wait event, signal event, allocate and free memory, dump memory if error, debugger for determining bugs, single step execution, locks for managing access to shared data between processes. So these are all the corresponding system calls, various system calls associated with the process control. File management system calls, creating a file, deleting a file, opening a file, closing a file, reading, writing, repositioning the file, get and set file attributes. Device management system calls, requesting device, releasing device, read, write, repositioning the device, get device attributes, set device attributes, logically attach or detach a device. For all these things we have a system calls. For information maintenance, gets time data, set time data, get system data, set system data, gets and set process, file or device attributes. Communication related system calls, create, delete communication connection, send, receive message if message passing model to host name or process name. If it is a client to server, shared memory model, create and again gain access to memory regions, transfer status information, attach and detach remote devices. Protection, control access to resources, get and set permissions, allow and deny user access. So system calls associated with that. Protection. System services. The system programs provide a convenient environment for program development and execution. So what are all the system programs for file manipulation, status information, program language support, program loading and execution, communication, background services, application programs. So all these are coming under system services. So it provides a convenient environment for program development and execution. Some of them are simply user interfaces to system calls, others are considerably more complex. File management system services for creating the file, deleting, copying, renaming, print, dump, list and generally manipulate files and directories. Status information, some ask the system for information, date, time, amount of available memory, disk space and number of users. Right, others detailed performance, logging and debugging information is also required. So like this, various services are provided. File modification, programming language support through compilers, assemblers, debuggers and interpreters. Program loading and execution through absolute loaders, relocatable loaders, linkage editors and overlay loaders. Background services and application programs. So these are all the various system services. Linkers and loaders. Source code, as a high level language, the source code is compiled into object file designed to be loaded into any physical memory location. So this is called as relocatable object file. So the high level language you are writing is compiled, compiled using compiler, and the relocatable object file is created. The linker combines these into single binary executable file. Also brings in libraries. So program resides on secondary storage as binary executable. Must be brought into memory by loader to be executed. The loader loads the corresponding binary executable into the memory. Right? So relocation assigns final addresses to program parts and adjusts code and data in program to match those addresses. Modern general purpose systems that don't link libraries into executables, rather dynamically link libraries, DLLs, are used. So during the course of execution they will be linked to the corresponding executable files. So with this diagram we will learn what is the role of linker and loader. See, for the source program you are writing main.c, right? That main.c is compiled and the object file is created, main.o, right? This is the use of compiler. Compiler is a translator which translates the high level language into object file, low level language. Now the object file is linked, okay? Using the linker, the object file is linked with the other object files. So like in C program you are writing stdio.h, stdlib. Some header files are including, right? For that header files you are not writing the code, so that the header files already is available. That header files will be linked with this your object file. Then it will be creating an executable file. This executable file in turn will be loaded to the memory through the loaders. Other dynamically linked libraries, that is available libraries associated needed by your program for the execution, will be linked during the course of execution when the program reaches the memory. Okay, so this is the typical arrangement at the background. It is done for executing any high level language, and the role of this linker and loader as a system program is highly important in the execution. Thank you.